So I should be streaming on YouTube. Yep. So I'm also live on YouTube now. Perfect. Hello, YouTube. Okay. Yeah. All right. So what is this? All right. So I'm gonna just extract some little bit of data set. Um, and that's where we're left off yesterday. I mean, the model was done today. I'm just going to create the overall data set, and then we're going to use that to train our model and say goodbye to Alexnet. So we have our training images here and our validation images as well. But we don't have the labels. Okay, so we have everything over here in a CSV file. And we can delete this zip. And now we need we need a we need something to do. Yes, so we need to write a script for our dataset loading part. So let's write that down. Um, Okay, so now we have a custom data set. Let's write the data loader part, but before that we need to prepare our data set. So let's do that. Import pandas as PD. Then we're basically going to say from torch dot from torch dot utils utils dot data import data set. Then we're gonna do from pill for pill import image, and then we can define um, we can say df is basically going to be pd.read csv file, and the csv file that we want to read is in the image. So we can just grab this, copy the path, but let's copy the relative path so it works on other systems as well. And then we can do um, so if it's is trained, then it's the training data set. If it's not trained, so for example, you'll see that all of these training images have been set to false, and when I get to the true part, this is when validation is true. So it's just a column representing um, let me see if I can. Okay, I can't open it as a CSV file. Can I do it here? No. But anyways, it just tells you like, is this a training image or is it a test image? So we will say that if is um, if is train, which is this comes afterwards. We can do data equals to df is valid, and let's call this data train. And if this double equals to false, dot reset index drop equals to true. So what this basically will do, I think there's not a function for head. I can just do it like this. We can write a function to get the length as well. So define length, and we can technically create a class. So let's do that. Let's call this class image net csv dataset, and then this is basically going to be from the dataset. So we can actually merge these things over here as well, but first I want to show you what I'm doing. um Come on. And we can set that the root directory is basically what we can define. So let's assume that our root directory Let's assume our root directory is this one. To be honest, this should be only done once. So there we go. That's much better. So we can grab this path. Where is it? Not this one, the relative path. So this is the root directory. And then to get this thing, we can say that the CSV file is basically at, let's import path for this. Or I think we need OS for this, sorry. So we need OS, import OS, and the CSV path to this thing is going to be equals to os.path.join, and then we put our root directory, and then we just add the name of the CSV file, which is this thing over here. So now if I write CSV file, that should give me, let me restart my terminal. Okay, so that's restarting. We're gonna wait a little bit. We are going to wait. Then we will begin. So and read CSV file or this thing. Let me restart VS Code. And it works. Okay. Okay, nothing. So we need to pip install pandas. I know how to grow your channel. Please let me know how to grow the channel. I would require some motivation or some tips. Walid Kul 157. I hope I pronounced that right. Or is it Valid Juyul? Ah, attention is all you need. Well, that is something that I don't have. I don't have attention at all. uh, is your name pronounced Valid or Valid or Valed? Okay, the implementation. I hope that you're having a good time. So it's valid. Valid. Okay, got it. Got it. In Germany, we don't pronounce W as W. We pronounce it as ve. So I think your name is valid. I think. Yeah. How are you doing, man? Um. Today, hopefully I'm going to complete the Alexnet architecture, just looking into how to import ImageNet. I saw your repository today on the Alexnet implementation. I'm not sure if you've added the dataset part yet. Let me see. Valid Kul. I forgot. It was in 92. Okay. Uh, I have your and you didn't update. I will add it by tomorrow. Okay, that is good, good news. How was your day, Walid? Was it good? Did you had fun? You told me you were playing Near Automata. Did you get the time to play Near Automata at all? Okay, let's create uh the class. Engine train.py. Okay, so I'm not defining the number of workers over here. I'm just defining the number of workers in the data setup file itself. Then what we can do is I can do class, and then we can say that this is going to be for my ImageNet CSV data set. And over here we can define an init function where we will have the self, we will have the CSV. Why am I doing it over here? I shouldn't be messing with my template. I should be doing it over here. Yeah. There. Then I have my CSV path, my root directory, and then comes my label column. Label column called the noisy labels 0. I think that's what it's called, right? Just a second. Okay, I am back. Okay. Let me remove the screen. Voila, we are back. Uh, let's take a look at the viewers. Viewers are almost the same. Nothing new in the chat. That is okay. Then we shall continue. Um, so yes, so we have the label column as the noisy labels 0. This is basically donating the image name. So this, then we have our another one which is train equals to true. So we will set this to false if you want the validation data set, and then the transform equals to none. Now after that we can then do yeah, technically we can push this into a different file. Yeah, we can do this in a different we'll do this here. And now let's define this entire thing. Whoops. Maybe here. Maybe like that. Okay. Then we will start with the function which is df equals to pt.read the CSV of the CSV path. Once we read that df, then we want to basically filter based on the is valid column, right? Is valid column. And what we're going to do is we're going to say if is train. So if it's true, then we're just filtering the data. df, so we're making a new df of the values where if it's false, then we're just dropping that thing. So if this is false, then reset index drop equals to true. So we are dropping those. Else self data equals to df is valid double equals to true dot reset index drop equals to true. So now that we have our filtered data frame, what we're going to do next is we're going to do self dot root directory and save that as our root directory. We're also going to get the transform as well. So transform equals to transform. And then we are going to do self dot label column equals to our label column. So yeah, then once we have done that, then we can also create a function for getting the length. So we're going to do is just return the length of the self dot data. We can create a new function called get item, and then again self and the index. So if you want to get an item, first we need the image relative path, and we can get this by saying self dot data dot ilock, which means that you are getting it on the basis of the index and the path. So and then we can also get the path of the image, which is going to be os dot path dot join the self dot root directory with the image relative path. So what we're doing is we're just grabbing um, this image. So this image's path is called this thing, but we already know what this is. So this entire thing is the image relative path. You could sorry, this is the root directory path, like that. And so I think maybe like this. And then this is your image relative path as this. And what you're doing is you're just um, joining both of them to get this entire path. That's what we did over here. And once we know what the path is, then all we can do is write image equals to image dot open, and then we can do image path dot convert into RGB format. So getting the 3 channels of the image, and then we can also get the label name. So the label name in our example is basically going to be getting myself just a second. Let me also explain how to get how to use iLock. So, yo, you're back. I thought you'll be back after a week. So I thought so too. Alvin, you. But then I was like, I'm gonna complete this paper this week. So I came back. And how are you doing? How was your day? Okay. Let us get back. So this is going to be iLock, and what iLock stands for is integer positional. So we're basically going to um, say that, hey, go to that row at that integer position that we are basically defining, and then get the path and return that path. So for example, I say, hey, give me the third the seconds, because it starts from 0 1 2, right? So sorry, this one starts with 0 1 2. So let me say if I want to get this row, then I say index 1, because this is 0, this is 1, and then I get the path, which is this entire thing. I'm not sure if you're still there, Alvin. Are you still there? Okay. Um, so that's how that's working. Okay. So we get the label name or the label column. So we have the path, we have the image relative path. We open it up, and then we get the label name. So self dot data dot ilock, again similarly index. This time we're going to get the self dot label column, and then we can say that the label is going to be self dot class to index and the label name that we just defined. So now we're going to do a little bit of pre-processing for the label name, which we can do over here. So use clean labels to establish the 10 class names, because right now it's very messy. So we do self.classes equals to sorted. So we're basically sorting it out on the basis of the unique values that we have. Noisy labels 0 dot unique. And then what we're going to do is we're going to do self dot classes to index equals to, which we used over there as find the class name and I for I. So for each number, so like 0 1, for I comma class name in enumerate self dot classes. So what we're doing is imagine these names as like cat, dog, maybe monkey, and then we have another one for cat. So we get these unique values. We get these unique labels. So for this case, it's like cat, dog, monkey, and then we sort them out. So this will be C first, D then second, and then M is third. And once we have sorted them, then what we're doing is we're going through each of them and we are basically returning an integer value and its class name. So class name will be stored over here, right? And the integer value will be like 0, 1, 2. So that's basically the idea. So the classes are stored here and the index is stored here. So that's basically what we did. Okay. Um, yeah. So now that we have the indexes to our classes, that's very, very good. Then we can continue with our transformation. Um, thing is, I don't want to apply transformation over here. I want to apply transformation. Um, hmm. Yeah, okay. We'll do it here. So with that get item, we can continue. Um, so we will have if self.transform image equals to self.transform, and then we can say, hey, we're transforming our image. Let's remove this because we're not using that anymore. And we have the label, and then we can basically return the image comma the label. Perfect. And then we can basically use this thing in our um, we can basically use this class now in our data loader. So here, where we basically are creating our data sets, right? We're just going to slightly modify this, and this is where we're basically going to use our ImageNet class. And the reason why we need this length is because this is basically going to be used when we create our data loader, and this is where it's referencing, and it knows how many images there are. So that's why you always need to also implement the length function as well. Okay, so now um mhm. We're going to also slightly modify this one as well. So we're going to have our directory. Um, so basically, uh, we're going to have our CS path, our root directory instead. Yeah, CSV path, root directory instead. We don't need this. And then we're going to have a separate transform for the training one. And we're going to have a separate transform for the test one, because they did mention that they used, I think, different transforms for the training set and for um, the testing one. So let me open the PDF. And over here, in the this section of data augmentation, um, at test time, we only do the horizontal one, the second one. Where did I read this? I think I read this that they don't do. Okay, so the color jitter is non-deterministic. You don't want to apply um color jitter, because if you apply color jitter, then you're also like changing the brightness and the contrast, and that's not the actual image. So that shouldn't be done. Okay, so training transform, test transform. Um, then moving on, um, we'll also add this thing over here as well. So the CSV path is the path to the CSV file, which contains the paths to the training and testing testing images or test images. Then we have the root directory, which is path to the root directory. Simple. Transform is the train transform. And then this is the test transform, torch transforms to perform on the training data. And this is on the testing data. And then we have our batch size, which remains unchanged, and the number of workers. Then an example to this will be added later. So you will have your CSV path, which is path to the CSV file. You will have your root directory. So this is path to the root directory. And then you have your train transform as some transform, and then you have also your test transform as some transform. Perfect. So we're going to do a lot of changes here. So the first thing is to create our training data set, or I can just call it train data. Our train data set, we're basically going to instantiate our ImageNet CSV data set. Then we're basically going to pass our CSV path. We're going to give our root directory. We're going to give it the is train equals to true, and the train the transform as our train transform. That's it. And similarly, we're going to do this for our test data set. So this will be set to false, and this one will be test transform, and that's it. And then we can just say this, that this is our train data set and this is our test data set. And that's pretty much it. That's all that we had to do over here. And then we can also return train data set dot classes, because we have already defined that over there. Perfect. So this is our let's call it image net data set. Then we have our data loader. Then we have our model, and then we can have our engine as well, or we can experiment whether our so let's call this as main, and we can basically test whether our data loader was successfully created or not. And to do this, first we need to specify our root directory. So yeah, so our root directory is basically going to be what this thing. So copy the path. So this, I think that's what our root directory is going to be. This slash just grab the relative path, much more easier. There we go. That's our root directory. Our CSV file is basically os.path.join. Join the root directory with what? With this thing. So let's do rename, grab this, put this there, and that's our CSV file path. Then we can specify our transforms. So we can say our train transform is basically what? Um, we'll have transforms dot compose, and inside this we'll have the first one as random resize crop as 2 to 4. And where am I basically taking these things from is from here. We do this by extracting random 2 to 4 by 2 to 4 patches and their horizontal reflections. So that's where I'm basically getting the randomized resize crop thing. Then I can have transforms dot random horizontal flip. Then we can have transforms dot color jitter with the brightness as transforms dot color jitter with the brightness as 0.2 and the contrast as 0.2. You can play around with these values. These are just random values that I'm trying right now. And then we can convert this transforms dot to tensor, the most important one because we work with tensor data. And lastly but not least, so normalize it. So normalize this with mean equals to, let me just copy this down, because these are renowned values. So we'll just use this instead of using 0.5, 0.5, 0.5, which was mentioned in the paper, because these are better values. And then we're going to do the same thing for our test transform. So this will be test transform. This time we want the image to be as original as possible. We can use center crop instead to still have 2 to 4 dimensions as our resize. And for that, it's all normalized in the same way. And yeah, that's basically it. We can also like give some other dimension as transforms dot is 256. So maybe if you as inference, because you're not training on a 300 dimension inference, you can give a stream stop. Yes, it did. Phone.